Welcome to Internet Quality Academy. The channel is for the quality control engineer, civil engineer, and the site engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction industry. Today also, I'm going to discuss about a very important topic that every civil engineer must know. That is how to perform concrete mix design as per Indian standard, that is IS 10262. I will describe in every step involved in the concrete mix design procedure, and that video will be on a longer video. So do not skip any part. If you skip any part, it will be very difficult to understand the full procedure. So stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's jump into the subject that concrete mix design procedure as per IS 10262. So mix design code is IS 10262 2019, but we need to check IS 456, IS 269, IS 383, IS 9103, IS 1489. So these are all the codes we need. One by one, I will describe and I will speak today Hindi and English also. सो पहले शुरू करते हैं हाउ टू perform mix design as per 10262. So first what we need to know, we need to know grade of concrete. What is grade of concrete? Grade of concrete is the minimum compressive strain in 28 days whenever we are testing the 150 into 150 into 150 cube, which means we are doing the 150 150 cube. So minimum strength at 28 days it's required, that is the grade. So here we are discussing about M40. That means the minimum strength should be M40 or 40 Newton millimeter per millimeter square or the MPa. So grade of concrete we decide that is M40. Now next part we need to know type of concrete. Why type of concrete? Because we have different types of concrete, that is the OPC, ordinary Portland cement, PPC Portland pozzolana cement, slag cement, rapid hardening cements. According to the requirement of the projects, we need to choose what type of cement we need to use, because whenever we are choosing the cement and according to the cement, the mix design procedure will change. And OPC 43, we are here confirming that we are using OPC 43 conforming to IS 269, because in IS 269 there are different grade 43, 33, 53. Now what is mean of OPC 43? OPC 43 means that minimum Q strength of the cement is 28 days is 43 Newton per millimeter square. So if you want to know about everything, what is OPC and what is the characteristics and what is the physical and chemical properties, I have made a detailed video. Link is there or in the description. Please check, you will get full information. So we are confirming this, our grade of concrete is M40 and we are using OPC 43 conforming to IS 269 2015. The next part is we need to finalize what is the maximum nominal size of aggregate, because aggregate is the main ingredient of the concrete mix design. But what will be the size? Because we have the different size, 80 mm, 63.5 mm, 40 mm, 20 mm, 10 mm, 6.5. Now we need to choose what is the maximum size. हमारा सबसे बड़ा साइज क्या है एग्रीगेट का? Here we are taking 20 mm. Why we need to take? Because we will see later that according to the size, the water cement ratio, the coarse aggregate fine aggregate ratio, and everything is changes because the properties is changing. So it is very much important to finalize that what is my maximum nominal size of aggregate. Here it is 20 mm. Now फिर क्या देखने का? Maximum water cement ratio to be adopted and or exposure condition as per table 3 or table 5 of IS 456. So why it is this maximum water cement ratio? All we know that whenever we are adding water, it start reacting with the cement and they make a hardened base, that is the concrete. So what is the minimum requirement or the maximum percentage of water मैं ऐड कर सकता हूँ? कितना मैक्सिमम वाटर हम दे सकते हैं मिक्स में? That has code provision. If we add more, then our concrete will not get that much of strength or the durability. So how we will select that one? Here it is saying as per table 3 and a table 5 of IS 456. Now we need to look that what is IS 456 is saying as per table 3. Here is the table 3. What is it saying? Environmental exposure condition. What is that? That means where we are doing the concrete. What is the area? That is what is that? Rainy area, hot area or the cold area or in the coastal area or whatever the other area that we need to finalize. मतलब कौन सा जगह पे हम कर रहे हैं और उसका इन्वायरमेंटल इफेक्ट क्या है, ये जानना बहुत जरूरी है. व्हाई? If we don't know the exposure condition, we cannot select the right kind of concrete for our projects. So here in table 3, there is 5 categories: mild, moderate, severe, very severe, and extreme. Now, according to the project location and the project requirement, we need to finalize the which category of condition is से फेवरेबल फॉर आवर प्रोजेक्ट. हमारा प्रोजेक्ट के लिए कौन सा कंडीशन इज फेवरेबल, कौन सा एनवायरमेंट कंडीशन इज अप्लाइंग, तो वो चूज करना बहुत जरूरी है. एंड अकॉर्डिंगली देन द फ्री वाटर सीमेंट रेशियो एंड द मैक्सिमम मिनिमम सीमेंट रेशियो विल बी अप्लाइड. So here is saying mild environmental condition. What does it mean? That concrete surface protected against weather or aggressive condition except those situated in the coastal area. That means if the concrete surface is protected, then it will be a mild exposure condition, but it should not be in the coastal area. And what is a moderate condition? Concrete surface sheltered from severe rain or freezing while weak concrete exposed to the condensation and rain. So it is protected from the environmental condition, that will be the moderate. And what will be the severe? Concrete surface exposed to severe rain, alternate wetting and drying or occasional freezing, that will be the severe. And a very severe, concrete surface exposed to seawater, spray, corrosive fumes and severe freezing condition with wet. Now what is the extreme condition? Surface of member in tidal zone, members in direct contact with liquid, solid, aggressive chemicals. Now, all we know that what is our location and how it is our exposure condition. So accordingly, we can choose what condition is applicable for us. सब हम इधर सीवियर कंडीशन को चूज किया. नाउ सीवियर कंडीशन चूज किया. नाउ हमको देखने का है कि नेक्स्ट व्हाट विल बी द इफेक्ट ऑफ सीवियर कंडीशन. नाउ वी विल गो फॉर टेबल 5. Now, what is in the table 5? Table 5 is mentioning minimum cement content, maximum water cement ratio, a minimum grade of concrete for different exposure condition with normal aggregate of 20 nominal sizes. So we check that our grade of concrete is 40 and the maximum nominal size of aggregate is 20 Now, our condition is severe condition, right? So here is reinforcement concrete, is plain concrete. Now we are discussing about the reinforced concrete. In the severe condition, what will be the minimum grade of concrete? That means minimum grade of concrete is M30. Below M30, we cannot use. So according to the our environmental exposure condition, we can find out that minimum grade of concrete M30, but we are using M40, so we are in the higher stage. Now, what will be the maximum water cement ratio? That will be 0.45. So maximum water cement ratio we can use is 0.45 and minimum cement concrete is 320 kg per cubic meter. These three parameter is very much important when we are dealing or when we are preparing concrete mix design. So according to my condition, minimum cement concrete is 320, maximum pre-water cement ratio 0.45 and grade is minimum M30. Look, next part we need to check. We have find out the water cement ratio maximum and everything. So here it is. Severe condition we have choose, and table 3 and table I is 456, that also we check. Next part we need to go, that is, let me see what is the fifth next condition, that is workability. And what is workability? That we all know that how is it is the concrete is makes, concrete transport, concrete place, concrete compaction. So these are all the operation how easily we can make, and that is called the concrete workability. And how we measure the concrete workability? The world accept method is concrete slam test. हम लोग स्लाम टेस्ट कर से मेजर करते हैं जो वर्केबिलिटी कितना होगा. नाउ व्हाट इज वर्केबिलिटी एंड व्हाट इज द इफेक्ट एंड हाउ टू सिलेक्ट राइट काइंड ऑफ वर्केबिलिटी? आई हैव मेड अ डिटेल video on this. Link is there or in the description. Please check. You will get the full information about the workability. Now in our case, whatever we are choosing, that slump is 75 and the minimum, what is the condition, that is clause 7.1 and 456, that is mentioning how you can select the workability of the concrete. The concrete mix proportion chosen should be such that the concrete of adequate workability for the placing condition of concrete and then properly be compacted with the mean of available. So these are the degree of workability: very low, low, medium, high, very high. We have choose 50 to 100, that is minimum, and it is non-pumpable. If it is a pumpable, the workability will be increased. That we'll discuss in separately. So in from clause 7.1 of IS 456, we need to choose what type of workability we require for our projects, whether it is a pumpable or not pumpable, that you need to finalize from your project requirement. So our is 75 is our workability. Next is method of concrete placing, that I have already discussed, whether it is a pump or non-pumping. Here it is non-pumping, that is we are using the concrete chute. Next part is degree of site of control, quality control. Why it is required? Because depending upon this, we need to find out the standard deviation of the concrete whenever we are selecting the concrete mix design. So whatever the degree of site control, good, very good, poor, good, that we need to check. Here we are checking that, considering the degree of quality control is good. So what we have already discussed, that is grade of concrete, type of cement, maximum nominal size of aggregate, maximum water cement ratio, and then exposure condition, and then workability, minimum cement concrete, then method of concrete placing, degree of site of control. And now we need to check the next part, type of aggregate. Why this is type of aggregate? I have already choose that maximum size will be the 20 mm, but what will be the shape? इसका शेप कैसा होगा? राउंड होगा, एंगुलर होगा, or flake hoga, that what the different types of aggregate is there. Here we are choosing crust angular aggregate. Why? Because it is widely available and easily available, so that we are choosing crust angular aggregate for our mixed design. And if we anything, that there will be properties will be changes, the moisture content, the moisture absorption property, angular space, that all everything will be changes, and accordingly the mixed design criteria will be changed. Now we have choose the crushed angular aggregate. The next part is maximum cement content not including fly ash. Now, as per IS 456, we have seen that the minimum cement content for this mix will be 320 kg per cubic meter. But कैन आई एक्सीड, कैन आई लिमिट, वट एवर, कितना भी हम ज्यादा कर सकते हैं क्या? 500 600 क्यूबिक केजी पर क्यूबिक मीटर? नो, दैट ऑल्सो कोडल प्रोविजन इज देयर, and that is 450 kg per cubic meter. This is the maximum limit of cement we can use in any mix. And where it is mentioned, I'm not saying this, it is mentioning in clause 8.2.42 of IS 456. What is saying? Cement content not including fly ash and ground granulated flash burner slag is not exceeds of 450 kg per meter square. So what I understand, that in not fly ash or GGBS, what is the supplementary cementitious material, other than that, cement should not be 450 kg. So minimum cement content is 320 kg. Now the maximum cement content is 450 kg. That is not fixed. So we will go to the next part. What will be the next part? Chemical admixture. Now we need to use the chemical admixture. Why? There are different types of chemical admixture: super plasticizer, retarder, air entrainer. So according to your project requirement and as per IS 9103, which is the code for chemical admixture, you need to select what kind of admixture is required for your projects. So if you want to know more about chemical admixture, I have made a detailed video. Link is there or in the description. Please check. You will get the full information about chemical admixture. So in our case, what is chemical admixture? That is super plasticizer conforming to IS 903. This is the code for the chemical admixture. Here it is using super plasticizer that will reducing the water content. So we will check what will be the percentage of admixture will be changes. Next part is specific gravity. Why specific gravity is required? Specific gravity is required for every material we are using to calculate the volume and weight for the mixes. So what we need to know, the Cement is 288. Sorry, it is cement is OPC we are using. That will be 3.15. It will be 3.15 will be the specific gravity of cement, and coarse aggregate at SSD, surface saturated dry condition, 2.74, and fine aggregate in at SSD, that is also 2.65, and chemical admixture 1.145. Now what is SSD? What is mean by surface saturated dry condition? That also you need to know. What is SSD? That surface saturated dry, the condition in which the aggregate has been soaked in water and has absorbed water into its pore spaces. The excess free surface moisture has been removed so that the particles are still saturated, but the surface of the particle is essentially dry. That means it has already soaked in the water, it is absorbed the what in the spore whatever it can take, but the surface is dry. That means it cannot take the more water. Why it is required to know that whether the aggregate is the SSD condition or in the dry condition? Because according to the condition, we need to adjust or you need to correct the quantity of water, and we also correct the quantity of fine aggregate or the coarse aggregate. So here we are discussing about the SSD condition. That means surface saturated dry condition. That means it is already in soaked water and absorbed water into its pore spaces. The excess free moisture has been removed. That means there is no free moisture, or it is, and it is in the surface, it is a dry condition. So that means it cannot take more water. So that means whenever we are pour water into the mixes, it will not, the water will not absorb by the aggregate, coarse aggregate and the fine aggregates. So that is why it is in the SSD condition. But it is very difficult to make it an SSD condition. So that is why we need to correct the moisture content, or also we need to correct the quantity of coarse aggregate, fine aggregate according, and also the free water which are adding into the mix. So these are the SSD condition for our in this condition. Now superplasticides are already used. These all these specific gravity we need to know whenever we are calculating the volume mixes. So we need to understand why. हमारा next part is water absorption. Now what will be the absorption? That coarse aggregate is 0.5% and fine aggregate is 1%. It is as per IS 383. You can check that one also. The next is moisture content of aggregate. Now here will be the coarse aggregate nil, fine aggregate nil. Why? Because we are taking the coarse aggregate and fine aggregate in SSD condition. If it is not SSD condition, then the moisture condition clause to be applied it. But here it is, we are taking SSD condition. That means the moisture content is nil for the coarse aggregate and the fine aggregate. Now the next part is sieve analysis. Why we want to do sieve analysis? Because what we are checking, what हम लोग ने क्या decide किया था, maximum size of the aggregate is 20 mm. So that is why we need to do the sieve analysis. Whenever we are getting the raw material, we need to perform the sieve analysis. That means after getting the sieve analysis, we need to confirm that this our aggregate as per the codal reference or IS 383. This is the code for the coarse aggregate and fine aggregate for the concrete mix. Now we need to do the sieve analysis. Here is the coarse aggregate and also in the fine aggregate. See the coarse aggregate, table 7 of IS 383, that we need to check. What we need to check, that is what is the sieve size: 80, 63, 40, 20, 16, 12.5, 10, 4.75, 2.36. And now whenever we know how to perform the sieve analysis, we have need to take the a certain amount of coarse aggregate or the fine aggregate and have to sieve, and you need to check how much percentage is written in each sieve. Here we are saying 20 aggregate. Now we need to, whenever we are percentage passing for single size, whenever only single size 20 aggregate, these criteria, that means in 40 100 100% to pass, in 20 85 to 100 pass, and 4.7 and pan. So these criteria has to pass whenever we are doing the single size or the 20 aggregate. But in our cases, we are always using 20 and 10 in mixing to get the proper aggregate. Why? If it is 20 mm, see here also it is saying 16 and 12 mm is missing. This 10 mm is missing. 4.75 is missing. 2.36 is missing. Now we need to understand why. What is that? How the concrete? कैसे होता है concrete? See, the bigger coarse aggregate, there is a void in between two coarse aggregate, and the smaller aggregate it will fill. Then the fine aggregate it will fill the finer void again. The cement cement binder as well as the filler will work, and it is make a homogeneous pores. So that is why our intention is to be always is a well graded aggregate, not the poorly graded. That is why whatever you're saying, we are always mixing 20 at 10 to get the right kind of blend. So that is why this table percentage passing from graded aggregate of nominal size, if it is 20 mm, that means we need to satisfy the criteria of this SIB analysis. If this SIB analysis is satisfied, we can say this is as per the TEB IS 383, and that can be used for our concrete mix design. So next is we need to check the fine aggregate. Fine aggregate, all we know there is a four zone: zone 1, zone 2, zone 3, zone 4 as per table 9 IS 383. And what will be the SIP designation? That is 10, 4.75, 2.36, 1.18, 600, 300, and 150 mm. Now, here we are getting always that zone 2 is the preferable. So we need to final check that one, these criteria is satisfying or not. We need to perform the SIB analysis, and according to the SIB analysis report, we need to finalize or we need to confirm कि हमको देखने का है हाँ ये grading zone 2 में है कि नहीं. If not, again we need to take the sample from other sources, or that we need to confirm that it is a grading zone 2. So these are the coarse aggregate and fine aggregate that you need to check according to the sieve analysis. And also you need to check the bulkage, you need to check the flakiness, you need to check the silt content. That all you need to check as per IS 456 in order to say that this material is okay for the concrete mix design. So these are the sieve analysis we have to prepare, and we have to select the aggregate for our concrete. Now, also the admixture, water, cement, that also you need to test as per the relevant IS code, and you need to confirm that all the material or the raw material we are using, that is mentioning or as per the code, and it is हम लोगों को जो कोड में लिखा है उसके साथ मैच कर रहा है, और वी कैन यूज इट. हम लोग इसको यूज कर सकते हैं कंक्रीट मिक्स डिजाइन के लिए. सीमेंट का टेस्ट होगा, दैट फाइननेस, साउंडनेस, ऑल आपको टेस्ट करके देखना है कि ये एज पर IS 269 है कि नहीं. एडमिक्सचर का भी सेम, वाटर का भी IS 456 के हिसाब पे उसका क्लोराइड कंटेंट, सॉल्वेंट कंटेंट कितना है, दैट ऑल्सो, एंड ऑल्सो पीएच कितना है, दैट ऑल्सो यू नीड टू चेक as per IS 456. So we have finalized all the raw material. We have finalized the raw material properties. Now it will come to the main part, that is the mix design part. What is that? First, we need to finalize the target strength for the mix. Now, we have already selected that our grade of concrete is M40. Now, what is this target mean strength? Target mean strength is mentioning in the IS 10262. Let me open IS 10262, and we will see on that how it is calculating. Okay, IS 10262, and we will check one by one that how we can select that one. See, there are two formula we need to understand in as per IS 10262. तो क्या है वो formula that we need to check? One first thing is FCK, that is FCK plus 1.65 into standard deviation. Now, what is standard deviation? Standard deviation, this is the we can easily find out in IS 456 or in the table 2 of IS 10262. Now, in table 10262, what is saying? According to the grade, standard deviation is this. So our case is it is M40, and our standard deviation is 5. So the formula will be FCK dot is equal to 40 plus 1.65 plus 5, that is 40.25. So we are getting 4825 Newton per millimeter square for our target main strength. Why it is required? Because it is whenever we are doing max design, it is in the controlled environment in the laboratory. So that is why this factor to be considered. That means whenever we are performing at the site, we will get the 40 Newton as a minimum. If you are designed for the 40 Newton, then we will get the below 40 Newton, which is not acceptable. That is why code has mentioning that your target mean strength should be different according to the grade and according to the standard deviation. So here is one criteria, and another criteria also, FCK plus X. Let me open IS 10262. That will be better for you to understand. See, here it is clearly mentioned. What is mentioned? It is mentioning that the target mean strength should be FCK plus 1.65 plus S, or FCK dot is equal to FCK plus X, whichever is higher. That means we need to finalize which one we should to check. One is FCK 1.65 into S. FCK dot is target mean strength, FCK characteristics, that is Newton 40 is standard deviation and factor based on the grade concrete as per table 1. So what will be happen? FCK is 40, 1.65 into standard deviation. I already checked that 5. It is coming 48.25, and FCK plus X we need to finalize what will be the value of X. Now, see, value of X. In our case, it is M40. So what will be the value? That will be 6.5. So here 40 plus 6.5, that is 46.5. And other what we are getting? Other area we are getting 48.25. Now, what is code is saying? Code is saying whichever is higher, that we want to accept as a target mean strength. So 48.25, 46.5. Now 48.25 is more, or is the higher. So what will be our target mean strength? That target mean strength will be 48.25. Why it is required? Because according to this, we will find out the what is our water cement ratio. So we need to calculate our mix design as per 48.25, and if we can find the one, then we can ensuring that whenever it will be performed at the site, we will get minimum 40 Newton per millimeter square, which is our characteristic strength. The next part is approximate air content. See, there will be air inside the concrete. So what will be the air content? Why it is required? Because whenever we are calculating the mixed proportion of the value, this air content is very much important, because this air content, whenever we are doing compaction or consolidation, it will become going it will इसको हम लोग निकलते हैं compaction के लिए, तो वो एरिया void हो जाता है. तो void ना हो जाए, इसीलिए हमको कैलकुलेट करना पड़ता है कि कितना परसेंटेज ऑफ air is there inside the mix. So what is our nominal size aggregate? 20, and it is 1. That is why I am saying in before that we need to finalize जे हमारा मैक्सिमम साइज है वो एग्रीगेट कितना है. सी 40 हो जाएगा तो 0.8, 10 हो जाएगा तो 1.5, but on our case 20, that is 1.5, where it is table 3 of IS 10262. Next is selection of water cement ratio. This is the most crucial and important things. Why? Because this is the things we need to check in water cement ratio. Next, on to check in the as per IS 10262. We will see how this can be checked. Let's see this. This is the curve we want to show. There is a curve 1, curve 2, and curve 3. There is 3 curve. And what is this 3 curve? And here it is, you can see. Let me open this one. The compressive strength of concrete, 28 is compressive strength, and here is a curve 1, curve 2, curve 3, and here is a free water cement ratio. Now what we know, and why this curve 1 and curve 2, curve 3? See, here it is written. Curve 1 क्या है? ये OPC 33 ग्रेड. कर्व 2 क्या है? 43 ग्रेड. कर्व 3 क्या है? 53 ग्रेड. नाउ वट एवर हमने क्या चूज किया था सीमेंट? OPC 43. तो हमको इस जगह में 43 का कार्ब माने कार्ब 2 देखने का है. नाउ क्या देखने का है? हमारा टारगेट मीन स्ट्रेंथ कितना था? 48.25. सो कितना होगा? इधर आएगा 48.25, एंड हियर इट इज मैचिंग. सो Accordingly to this, it will come around 48 here, curve 2, and it is coming, it's around 0.36. नाउ एक क्वेश्चन आ सकता है कि अगर हमने ओपीसी यूज नहीं किया, पीपीसी एंड अदर किया, तो क्या होगा? अब देख लीजिए, नोट में लिखा है, इन द एब्सेंस ऑफ डेटा ऑन 20 स्ट्रेंथ कार्बन कार्ब 2 मे बी यूज फॉर ओपीसी 43 एंड 43 while using PPC or PSC, the appropriate carb as per the actual strength may be utilized. In the absence of actual data, carb 2 may be utilized. So for OPC, 33, 43, 53, carb 1, carb 2, carb 3, or other PPC and PSC is carb 2 to be used. So from here, you need to finalize what will be the free water cement ratio. So here, how much we are getting free water cement ratio from the curve? We are getting 0.36 from the figure. Now, maximum water cement ratio from table 0.45, how much you are getting? It is 0.45. From 0.45, I hope you remember that IS 456 from table 5, as per the exposure condition, we find out that maximum water cement ratio can be 0.45. Beyond that, it is not acceptable. But in the figure, as per the target mean strength, we are getting 0.36, and it is safe because we are getting less. So 0.36 can be okay. Now, next part is selection of water content. So what we are getting, that we are getting 0.36 is our water cement ratio. Maximum size is 20. Now we need to check the what is the water content. So why water content? If we find out the water content, we can easily find out the cement content. So first things, we need to find out what will be the our water content. Now we need to check the table 4 of IS 262. uh, from that, what we will get? See, let's see what is table 6. Table 6 is saying water content per cubic meter of concrete of nominal size of aggregate. Now, what is our nominal size of aggregate? We have chosen that is 20. And what will be the water content? That is 186. So 186 cubic meter we are getting from table 4 of IS 10262. But it is not finalized yet. We need to correct that one. Adjustment we need to know as per clause 5.3. What is quite rounded gravel or reduced workability for the desired workability other than 50 slab. Here it is in clause 5.3, it is mentioning it is for 50 slab. That means if my slab is 50 it will be accepted, that is 186, or we will choose 186 cubic meter kg per cubic meter of water if my water cement aggregate is 20 and my slump is 50. But what is my slump? My slump which is 75 right? So other than that, the required water cement may be increased or decreased by about 3% for each increase or decrease of 25 slump. Now this has to corrected. We are getting for 50 in our case, what is that is 75 now it is increasing 25 so it's saying 3% to be increase or decrease in increase or decrease of water the slump content. So what will be our adjustment of this content? That is, it is increasing, so that means we need to add more water for this add. So that will be the how much? That will be the 3% of every increase of 25. Here it is, or you are 75, that means 25 mm increase हो रहा है. In case it is our 100 that means 50 increase हो रहा है, तो 6% we need to increase. So what is maximum? It is 198.58 kg. So corrected water is 191.58 kg. Now water cement content with super plasticizer. You remember that we are using super plasticizer because if we are using super plasticizer, it will reduce the water cement ratio or water content. Why? If it is water content is less, or that will be workability will be the same, but our strength durability will be the more. So what will be the dose? It is also in the mention in IS 10262 in annexure. Please check that dose will be the 1.5% and maximum we can use from the 20 to 30%. Here we are accepting that 23% doses we will use as for the water content. So what will be the minimum water actual the corrected water? First, we choose the water from the table, it is 186. Then we corrected as per the slum. Now we need to correct it as per the using of the what admixture. Now we are saying that 23% water can be reduced. So water will be 148 kg, 198.5 into 0.77, it is 148 kg. So my now I have find out my water content, that is in 1 cubic meter 148 kg water can be used. Next, whenever I find out the water, the next part is calculation of cement content. Okay, so what is my water cement ratio? That was 0.36. Remember, from the graph we are find out. Now I got the 148 kg per cubic meter, that is my water. So 145 into 0.36, that will be 412 kg, that is my cement consumption for 1 cubic meter of cement. So this is the 4152 kg. Now we need to check whether this is valid the code or not. So there are two criteria. What is the minimum and other is maximum. What is the minimum cement content as per the requirement of the exposure condition? That was, remember, 350 or 20 kg. So it is 412. That is okay. And another thing also, what is the maximum? Maximum is 450 kg, as I shown you before. This is as per IS 456. So it is in between minimum and the maximum. So this can be accepted. So what is my water? Water is 148 kg and the cement is 412 kg. Now we need to check the calculation of admixture. So why calculation of admixture? That is also important because we need to know what is the how much percent, how much total quantity of admixture we need to know, because it admixture also आपका concrete में रहेगा, तो इसका volume और weight that also you need to calculate. So 1% of total cement एडमिक्सर डोज हमने सिलेक्ट किया था 1% ऑफ टोटल सीमेंट. सो कितना होगा? 412 kg का 1%, 41.12 kg. So admixture is 4.12 kg. So what we find out immediately? Water 148 kg, cement 41 kg, and admixture 4.12 kg. So what is balance? Balance is our post aggregate and fine aggregate. This is a tricky one. थोड़ा ठंडा दिमाग से सोच देखने का, हम एक एक करके अब बताएंगे, क्योंकि ये थोड़ा ट्रिकी वन है ना. सो इनको आपको ठंडा दिमाग से सोचने का है. हम धीरे धीरे बताएंगे, आप एक एक करके देखिए. टेबल 5.5 एंड टेबल 5 ऑफ IS 10262 आपको देखने का है. चलिए टेबल 5 में चलते हैं. टेबल 5 में क्या है? IS 10262 का टेबल 5 देख लीजिए. ये टेबल 5 है. ये टेबल 5 में क्या बता रहा है? वॉल्यूम ऑफ कोर्स एग्रीगेट पर यूनिट वॉल्यूम ऑफ टोटल एग्रीगेट फॉर different zones of fine aggregate for quarter cement ratio, material ratio of 0.5. Now, this table is showing for 0.5. Okay. If my water cement ratio is 0.5, this is valid. Okay. But if it is not, then this is not valid. That is why we need to correct it, or we need to multiply the factor. कैसे उसको correct करने का है बाद में आते हैं. हमारा zone क्या था? zone 2. हमारा maximum size of aggregate कितना था? 20. So हमारा 0.62% will be the कोर्स एग्रीगेट पर यूनिट वैल्यू टोटल एग्रीगेट ऑफ फाइन और डिफरेंट जोन ऑफ एग्रीगेट. सो क्या है ये? मान लो कि कोर्स एग्रीगेट और फाइन एग्रीगेट एक है, तो एक के अंदर कितना परसेंटेज कोर्स एग्रीगेट होगा? दैट इज 0.62. दिस इज नॉट फॉर द total volume of the concrete. Please listen to this. ये क्या है? ये टोटल वॉल्यूम का 0.62%, 0.62 नहीं है. ये है कि टोटल कोर्स एग्रीगेट और फाइन एग्रीगेट का वॉल्यूम अगर एक होगा, उसमें 0.62 प्रपोर्शन होगा आपका कोर्स एग्रीगेट, एंड 1 माइनस 0.62%, दैट इज 0.48% होगा आपका फाइन एग्रीगेट. डोंट कंफ्यूज विद द टोटल volume of concrete. That will be the different one. It is for coarse aggregate and fine aggregate. So हमने क्या मिला हमको? 0.62. अब क्रॉस 5.3 क्या बोल रहा है? एक बार देखना है. क्लॉस 5.3 सिलेक्शन ऑफ कोर्स एग्रीगेट ये बोल रहा है कि आपको देखिए, or aggregate of a 5.5 aggregate of essentially the same nominal maximum size typical and grading will produce concrete of satisfactory workability when a given volume of coarse aggregate per unit volume of total aggregate used. In table 5 water cement ratio cementation material ratio zero point 0.5 which may be suitably adjusted for other ratio. That means my ratio, what is my water cement ratio is 0.36. Now we are getting 0.62 for the 0.5 water cement ratio. Now we need to adjust. And how to adjust? देखिए क्या लिख रहा है, the proportion of volume of coarse aggregate to the total aggregates is increased at the rate of 0.05 for 0.01 for every decrease in water cement ratio per 0.05. तो इसको जितना ये हो रहा है, मतलब इंक्रीज टोटल एग्रीगेट पार्ट ज्यादा होने जाएगा, जो भी वाटर सीमेंट रेशियो कम होगा। क्या परसेंटेज क्या है, 0.01 में 0.005। नाउ दिस इज वेरी वेरी मच इंपॉर्टेंट। हमने जो 0.62 एक्सेप्ट किया दैट इज फॉर 0.5 और हमारा 0.36 है वाटर सीमेंट रेशियो। दैट मीन्स फॉर 0.14 वी नीड टू एडजस्ट द to aggregate volume for the total mass of aggregate plus fine aggregate. So आप देखते हैं कैसे इसको कैलकुलेट करते हैं। Again, go to my mind map. Okay, see, we are getting 5.5. Now we have to volume of coarse aggregate. See, 0.62 plus 0.5 or 0.36. That means कितना decrease हो रहा है, 0.14, और कितना रेशियो है 0.015 पर 0.05 of वो cement ratio. So कितना होगा 0.62, 0.028, 0.648. So these 0.648 is my volume of coarse aggregate in total volume of coarse plus fine of aggregate, and volume of fine aggregate 1 minus 0.648, 0.352. So 0.645 percentage, 4 point percentage is coarse aggregate and 0.352 is percentage of fine aggregate. But again, it is not or 1 cubic meter concrete, it is total of coarse and fine aggregate. What will be the percentage? That is 0.648 and 0.352. And again, this water coarse aggregate percentage को भी हम लोग एडजस्ट करते हैं जो अभी इट्स अ पंपेबल कंक्रीट होता है। IS 10262 बोलते हैं कि मैक्सिमम वी कैन रिड्यूस 10% और coarse aggregate whenever it is a pumpable concrete, because we need to transfer concrete from one place to another place or in the vertical. That is why this coarse aggregate also can be adjusted as per the pumpable concrete. For now, we have selected that it is not the pumpable concrete. That is, we are taking 0.648 and 0.358. Please, this proportion is very much important. That from table 5, we are getting 0.62. That is for 0.5 water cement ratio, and after that we have to adjust it or reconnected that to correction made for difference of water cement ratio, and increase is 0.05%, what increase of 0.05 water cement ratio, it is coming 0.648, and 0.648 is a percentage of total coarse and fine aggregate, not the total volume of concrete. So what are we getting? We are getting water content, water getting cement content, we are getting admixture content, and we are getting the proportion of coarse and fine aggregate in the mix. Now we need to calculate the coarse aggregate and find out. For that, we need to calculate the mix volume. Why? Now we are getting cement, we are getting water, we are getting admixture, and we are getting what is percentage for coarse and fine aggregate proportion in a not in a mix, in a total quantity. कोर्स एंड फाइन एग्रीगेट का टोटल क्वांटिटी का कितना परसेंटेज कोर्स एग्रीगेट होगा, कितना फाइन एग्रीगेट होगा, वो हमको मिल गया। पर हमको अभी देखने का टोटल कोर्स एंड फाइन एग्रीगेट कितना है मिक्स में। कैसे? हम जानते हैं कि 1 cubic meter वॉल्यूम है कंक्रीट का, हमको सीमेंट मिल गया, एक वाटर मिल गया, एडमिक्सचर मिल गया, इसको माइनस करेंगे तो हमको कोर्स एंड फाइन एग्रीगेट का परसेंटेज मिल गया। लेट्स डू दैट वन, because this is the main. Now, what is the total volume? 1 cubic meter. And what is the entrapped air? That is 1%, already we check as per the table. And what is that one? 0.01 cubic meter. And the cement volume, that will be see what is the, we are getting 4.12 we are getting. So it is 4.12 divided by the specific gravity into 1000, it is 0.143 cubic meter. And volume of water 148 divided by the 1000, 0.148 cubic meter. Volume of admixture 4.12, 1.145. The specific gravity we have already checked. it is coming 0.036 cubic meter. So in a 1 cubic meter volume mix, we have already find out cement volume, water volume, and admixture volume. Now, if we minus this one, what we will get? We will get the volume of coarse aggregate and volume of the fine aggregate in total. So let's do that one. What is the volume of coarse and fine aggregate? A minus B. Why A minus B? A is total cubic meter minus the interrupt air. Air is 1%. So total mix will be 1A minus B. Then minus C plus D plus E. That means cement volume, water volume, and admixture volume. So water we are getting 0.695 cubic meter. See, we are getting 0.659 cubic meter total coarse and fine aggregate. But how much percentage of total is coarse and fine aggregate? Let's see. Mass of coarse aggregate 0.695 into 0.648. From where we are getting? See, टोटल मासेस 0.648% आपका कोर्स एग्रीगेट था टोटल वॉल्यूम का। तो टोटल वॉल्यूम ऑफ कोर्स एंड फाइन एग्रीगेट 0.695, इसका 0.648%। तो कितना हो रहा है? स्पेसिफिक ग्रेविटी से करेंगे तो 12345 kg। द सिमिलरली मास ऑफ फाइन एग्रीगेट कितना होगा? सी 0.352%। So mass of fine aggregate will be 0.695 total volume of coarse and fine aggregate into 0.35 to 2.65 into 1648 kg. So now we are getting everything, cement, sand, water, and everything. So what will be the trial mix proportion? Because this is the theoretical we are getting. Now what is the getting? We are cement 412 kg, water 148 kg, coarse aggregate in SSD condition 1234 kg, fine aggregate in SSD condition is 648 kg. Let me write that one. That is 648 kg. And what is admixture? 4.1 kg, and free water cement ratio is 0.36. Now I am getting my mix proportion. Now what do we need to do? We need to do the trial, and we need to wait for the 28 days trend, so that we need to verify whether this mix is as per the design or not. Now this has the one condition, that we need to correct the moisture condition, and accordingly the coarse aggregate, fine aggregate percentage, and the free water percentage is changing. But you remember, we have all taken in the SSD condition. That is why is not required for the correction. But if it is not in the SSD condition, we need to correct it, the coarse aggregate percentage, coarse fine aggregate, and the water content. So these things we need to check whenever we are doing the concrete mix design as per IS 10262. So step by step I have made this one, and I think I have made this one okay, and आप लोगों को समझ में आया। और अगर आप लोगों को समझ में आया तो मेरा ये whatever the strength, whatever I have made, it will be valuable for me. And I'm waiting for your valuable comment. If you're stuck any point to do the concrete mix design, please let me know. I will help you to do that one. And I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And please do not forget to like, share, and subscribe. And if you are stuck in your quality control career, the link is there. Please click in the link and book a one-to-one clarity call, which is completely free, and I will uncover the secret of quality control success. And I'm waiting for you. I'm waiting for your valuable comment, and I'm waiting for your like, share, and subscribe. And thank you once again for watching me.